Hello everyone, welcome to our EXA4MIND webinar. The webinar is about smart farms and extreme datasets. My name is Evgeny Bogdanov. I represent the company Terraview in EXA4MIND consortium, and I'm going to talk about how we can optimize water usage and how we can improve yield in agricultural fields and show how EXA4MIND technology can help us and why it is needed. EXA4MIND is a European project that helps us to work and improve with extreme large datasets. Why Aquaview? What is the problem with soil moisture? So today around 70% of water usage accounts for farming, and quite often the water is not used efficiently. There is a lot of water that is wasted, and we are going to have a problem in the future when it comes to the fresh water. There is also a big problem with soil health, so it's a big concern. And the irrigation, it influences the soil health. So for instance, too much water, it can compact the soil, so the soil becomes too compact and the water cannot reach the roots of the plants. On the other hand, too little water, it also deteriorates the topsoil. It becomes dead and like drought, etc. It destroys the soil. And the irrigation costs, they are also increasing, and it's an additional concern to be considered or taken into account. So there are two main challenges. So one challenge is to precisely understand the soil moisture content. There is a solution on the market, so we can use the soil moisture probes to identify it. However, those soil moisture sensors, they provide only point data, so they don't cover the whole estate, like vineyards estate, for instance. Or it might be, if you want to cover the whole estate, then it becomes very expensive because soil probes, they cost money. And the sensors are often, it's not reliably installed. So it also requires some knowledge how to install the soil moisture sensors so that they properly measure the soil moisture. And another problem is that agricultural fields, there are a lot of operations that are going on the fields, and those soil moisture sensors that are installed, they might get destroyed. And the challenge number two is we need a precise measurement of soil moisture on each field, and not only on each field, but even on the parts of the field. So the map needs to be very granular of the soil moisture. And the other issue is that today the satellite indexes, they only measure the crop water stress, and they don't necessarily measure the soil moisture. So here where we come up with the solution called Aquaview that we are going to demonstrate now. So Aquaview, it's the standalone soil moisture tool that can evaluate or estimate the soil moisture on the granular level. Here there is this is how the Aquaview platform looks like. So we can set up an agricultural field, so we can have the polygons representing agricultural fields, and then we can run our Aquaview analytic. And once we run the Aquaview analytic, we get a map like this. So those are the blocks of 30 by 30 meters. And for each block, as you can see here, we measure the soil moisture. For instance, for this one, we have around 27% soil moisture. For this block, we have around 50% soil moisture content. And the color represents the soil moisture. So what we can see already here is that this part of the field, it has high soil moisture content, and this one has a lower soil moisture content. So if I was an irrigation manager, I would decrease the amount of water that I put on this field, and I would increase the amount of water that I go get to this field in order to equalize the soil moisture over this field. The way it's working, we are using satellites to provide this soil moisture map. And what you see here on the left, it's the calendar. So it's a calendar where we have the data. In this case, it's on 12th of August. This is the analysis of the field on the 12th of August. The problem with satellite soil moisture measurement is that satellites, they are not very frequent. So we might get the satellites, some of them they are running every 5 days, the others they are running every 10 days. And on top of it, there is a problem that sometimes imagery might be broken, or there are clouds that prevent us from building this soil moisture map for a particular day. So what we can see here in August for this particular field, we just have one data point. In order to address this problem, we developed an AI model that takes multiple parameters into account that we are going to discuss later. And then it provides the soil moisture map in the more granular intervals in time. And also we can go deeper in the soil, so we can provide some additional depth. So what I'm going to show now, I'm going to show how it's working. So what we can see here, now each day in the calendar has some values. And if you look at the number 8 here, so 8th of May, so we have a green part. So green part represents measurement from the satellite. And on top of it, for each day, we now have these pink dates. So that's where we run the model. So when we don't have the satellite based measurements, we can run our AI model and to generate soil moisture map. So for instance, if I click now on the 8, so I have a new map now. And the other thing is what we see here, we see now the timeline. So it's not like for this day, 8th of May, we don't have one measurement, but we actually have 24 measurements. So here, each hour we have a slightly different map. So if I click at 10 or like 14, so I get the map, soil moisture map that is different, which is relates to what is the temperature around, how quickly the water evaporates, plus also on the content of the soil, how much clay is there, how much sand is there, etc. And additionally, if we have the soil moisture sensors that are measuring soil moisture at different depths, AI model can use this information and provide the predictions of the soil moisture not only in time, but what we see here on the right, it's a depth. So we can click on 30 centimeters and see what's the soil moisture at the 30 centimeters depth. So this is how the AI model is working, and this is how Aquaview works and how it can be used for irrigation purposes. So what we saw here, it's the standalone tool that can be used for any type of crop or other purposes for measuring soil moisture content. And as we discussed earlier, so the soil moisture sensors, they are quite expensive. So by using this tool, we can decrease the amount of the expensive probes, but we can still cover the whole estate or the whole farmland of a particular farm organization. And we provide hourly insights or daily insights for irrigation optimization based on the Aquaview tool. And as I said before, so Aquaview is a standalone tool. It's not crop specific, it's crop agnostic. And next we are going to show you Gamaya Viewer, so which is a tool built for farming for different types of crops. And we will show how this Aquaview tool integrates within a bigger farm portfolio. And as the topic of this webinar is smart farms, we will also show a set of tools that are using drone imagery, satellite imagery, and other data sets to provide insights for farmers. So if we jump here to the demo of this of Gamaya Viewer, so we see a set of fields here. So each block here with a number, it's the vineyard. Those are locations in Portugal. And for each, so we are going to talk about growth monitoring tool. So that's what we are going to discuss next. Growth monitoring, we will see how it's working in time, how it helps us to identify the health of the fields. We will look at the individual field analysis, and also we will look at the tools that are available for multi-year comparison. So first we start with the growth monitoring. So that's what we see here. So we see on the right the NDVI index. So that has a numbers between 0 and 1, and 1 meaning the good vegetation, 0 meaning no vegetation at all. It can be bare soil or when there is no vegetation. And each field is colored based on average NDVI for this field for a particular date. So we can go back in time and explore what was happening with those fields in time, like what was the NDVI index on those fields. So that's the overall analysis of several fields on the farm that we can quickly spot that some fields might be problematic. Well, here these two fields are in red, so maybe something needs to be done with those because the whole field is red. But it might be also just it was freshly planted and it's bare soil, so it's this is why it has a low NDVI index. So if you look at this particular field, so now we don't only see this analysis of all fields, but we can go and analyze this field individually. So what we look here, so we see here an NDVI graph, so how the how vegetation is developing in time, which can provide some hints to farmers if something is going wrong on the field. And here what we also show to farmers, we show temperature, average, minimum, maximum on each particular day. We show precipitation, and we show an important index which is called water balance or water deficit, which is shown here in green and red. So red, it means it's the hydric deficit. And for plants, so it's important for farmers to understand this hydric deficit or hydric balance, because this is what defines how much irrigation they need to do. So this is more precise because it also takes into account evaporation, evapotranspiration, and type of soil. And in this particular case, for this vineyard, so here it's quite a lot of quite negative water balance, meaning hydric deficit, and this field requires irrigation. Then what we can do next, we can do a deeper analysis of the field. So there is of NDVI field. There is the classes checkbox that we can click. And once we click it, then we have we can analyze this field more in details. We see that something happened here. Maybe it was just the field was part of the field was reworked, but it's the low NDVI index. And we can play with those parameters to kind of highlight where the problems are. And what we see in this particular field, that there is some problem here and there is some problem with vegetation in this part of the field. And by using this, the client or the farmer can decide that they would need to go and check the field. So if they already know what the problem is, they can estimate the size of it. For example, if there was a frost or drought or something like this. So next we are going to look at the cross-year comparison. So if we open this tool again, so we see the compare by seasons, and if I choose the season 2023 and 2024, so I can see the growth or the health of the plant, and I can do a comparison between the 2 years, and we can see that in season 2023 there was the higher vegetation on this field. So potentially something happened that in 2024 it might have had less yield because of different factors. Maybe it was not irrigated enough, or maybe there were pests or some other problems on the field. So this is what Gamaya Viewer has in terms of the analysis of the health of the fields. And the next what next we are going to look at the yield forecast. If we come here, so we see the second item here called vineyard, and that's where we provide the yield analysis. So all those fields, they are colored now by the amount of yield or like how many kilograms or tons of grapes they're going to get from each individual hectare. And those are the different ranges for those fields. This information is important for farmers, because they want to know how much tons of grapes they are going to get from each field, because this defines how many bottles they need to have for wine, and how many barrels they have to buy or to order in order to have for this particular season. And if you click at the field, then we have the growth curve here, how the grapes are developing in time. Plus we see that in total this field is going to have 95 tons with the average density of 8.1 tons per hectare. In order to provide this solution for clients, we have an AI model that does yield prediction. The way the AI model is working is it takes several parameters into account. It takes it takes vegetation indexes into account. So this is what is coming from satellites. It takes weather into account. So what we already discussed: temperature, precipitation, solar radiation, hydric balance. The fields have some agronomic data on it, which is type of variety that is growing on this field, how old the field is, like how many seasons in terms of the vineyards, because some fields they might grow for 20-30 years, the wines. Crop age in this particular season, and also what kind of soil is growing, what kind of soil is in this particular field, what is the clay percentage, organic matter, sand, etc. So that's also part of the model. And then farmers provide us harvest data from the previous season. All this data comes into training a deep learning AI model that is able to forecast for the next season how much yield they are going to have. So when we are training the model, we test its performance. So we measure accuracy, how good the model is working, and then we deploy this model into our production platform. And in the production platform, the model takes the current season data into account. It runs the model, and every Monday it generates the forecast of how much tons per sugar a particular field is going to have. This is about yield forecast modeling. And the next topic we are going to look at, again, we are going to look at the soil moisture maps, but now how it's being integrated within a particular vineyard, not just as an individual field. We'll be looking again at Portugal, but in a different vineyard region. This time it's in the north of Portugal. And what we see here, it's the Aquaview being plugged in Gamaya Viewer. So we already looked at the growth monitor in vineyards, and now we are looking at the soil moisture. So here for each field we have a color. So and the color represents how what is the percentage average soil moisture content on this particular field, which allows us to generally understand how different fields are going. We can see that in the north the fields have more soil moisture, and in the south it becomes more towards red or orange, meaning that the soil moisture there is lower than in the north of the region. This is the analysis of the field in general. And then if we click on a particular field, as we were seeing before in Aquaview, so we have the soil moisture legend with the soil moisture, and then we have these regions of 10 by 10 meters, and we can see what is the soil moisture map of this particular parcel. So this is how the tool is integrated in Gamaya Viewer as a part of other solutions for smart farm management. So how is it working? Because, well, what you see here, you again see just one data point. So it's the fields here using satellite Aquaview tool. So we don't have a lot of frequency, or we are not able to predict the soil moisture at depth, and we are not able to predict soil moisture every hour or every day, because if we only use satellites, we don't have enough frequency of the data. This is where our AI model comes into play, and also the soil moisture sensor. So AI model does data fusion of several sources, which is soil moisture, satellites, etc. So I'm going to show how the model looks like in just a bit, but here we are demonstrating how the soil moisture sensor is working. What we can see here on the picture on the right, so that's the soil moisture sensor that is plugged into soil, and that's the computer with the battery that is managing the data transmission. Plus, in addition, you can see here the solar panel that allows this soil moisture device to function without need for electricity. So this is the soil moisture sensor, and it transmits the data into cloud where our AI model is working. AI model for soil moisture, it's the diagram is similar to what was shown before for the yield model. So it takes vegetation indexes or satellite data into the model. It takes weather data, and in addition to the historical weather data, we are also taking into account 14 days weather forecast. So the model can not only predict past, but it can also forecast the soil moisture map in the 14 days that follow based on the weather forecast. Then what is important from the fields for the soil moisture, it's a soil type, how much clay and sand, what is the structure of the soil. So those maps, they also become part of the model. And in addition, the soil moisture sensor that we just showed before. So this is also provides information into the model, those continuous in time readings, and those readings might come at a different depths. Then the soil moisture deep learning AI model takes all those parameters into account, and we train the model, and then the model is able to predict the soil moisture content at different depths and at different time intervals. And this is what is plugged after into the tool, so that we can provide the data every hour and at different depths. This is the soil moisture model, and that's how Aquaview tool is integrated into Gamaya Viewer as the part of the Smart Vineyards portfolio. And in addition to the tools that we showed before, which are based on satellites, the Gamaya Viewer also supports the drones. So drones, they provide high resolution mapping. It can be RGB or it can be multispectral, and it can be even hyperspectral if the hyperspectral camera is installed on the drone. It complements satellites and AI model, and it provides validation ground truth and higher resolution compared to satellites, because different analytics for satellites, it can run from 4 to 30 meters resolution, and the drones here, they provide resolution of 3 to 4 centimeters. So again, so that's a drone that is flying on the left over the vineyard field, and on the right we see the map that I'm going to demonstrate now in the tool. Yes, so if we open here the drone analytic tool and we click on a particular field here, we see this vegetation index that is built from the drone, and it helps farmers to analyze better what is going on the fields. For instance, for vineyards, they could detect the gaps in vines, because some vines are dying with time, and that can be an important metric for them to decide if they want to rebuild the field and to destroy it and plant new vines, for instance. And in addition to vegetation index, we also provide the RGB imagery for this particular field. That's how drone analytics are complementing satellite and Aquaview tools for the smart vineyards solution. However, there is a problem for agriculture, because it requires a huge amount of data sets. So what we demonstrated various Aquaview tools and Gamaya Viewer tools related to yield estimation, health analysis, and also drones, and all those, they require extreme data sets. For instance, for analysis of the Czech Republic that we did, so the first data that is available since March 2013, so it makes it almost 600 weeks, and on average we get 70 gigabyte of data per week to do the analysis that we are doing, which makes it approximately 38 terabytes of data just for one, like for us, for Terraview, for one partner in the EXA4MIND project. And that's where EXA4MIND comes to help. It allows us to improve and to simplify and to speed up our analytics. We have those huge data sets, and by using EXA4MIND solutions, we are able to significantly decrease the amount of data that is being downloaded by our tools. And it both allows us to do it faster and smaller data size transfer, which allows us to deliver the results quicker to the clients, and in general to save on the cost of processing for agricultural analytics. And that's the goal of the EXA4MIND project, is to help different industries to work with the extreme datasets. And Terraview is a partner in this project, and we are running our Aquaview and other tools and we are benefiting already from the EXA4MIND tools. This is the first webinar. We are going to have 2 more webinars on the usage of Aquaview for agriculture, and in the next webinars we are going to go more into the technical details, how those solutions are working and what are the benefits we are having from by using EXA4MIND toolset or EXA4MIND platform. Thank you very much for your attention. My name is Evgeny, as I said before. Thank you for your time. Bye-bye.